हेलो एवरीवन एंड वेलकम टू TalentSprint। इस सेशन में हम डिस्कस करेंगे टाइम एंड डिस्टेंस, जो कि क्वांटिटेटिव एप्टीट्यूड का एक और बहुत ही इंपॉर्टेंट एंड पॉपुलर टॉपिक है। ऑलमोस्ट सभी एप्टीट्यूड बेस्ड कॉम्पिटिटिव एग्जाम्स में इस टॉपिक से क्वेश्चंस पूछे जाते हैं। वैसे तो ऑलमोस्ट सभी क्वेश्चंस के लिए यहाँ पर कोई ना कोई शॉर्टकट फॉर्मूला होता है, लेकिन अगर आपके बेसिक कॉन्सेप्ट्स एंड फंडामेंटल स्ट्रांग हो तो आप इन क्वेश्चंस को बिना शॉर्टकट फॉर्मूला यूज किए भी बहुत इजीली एंड क्विकली सॉल्व कर सकेंगे। तो चलिए डिस्कस करते हैं ये बहुत ही इंपॉर्टेंट टॉपिक, टाइम एंड डिस्टेंस। तो जैसे कि आप इस टॉपिक के नेम से समझ सकते हैं, यहाँ पर हमें टाइम और डिस्टेंस से डील करना है, राइट। इन दोनों वेरिएबल्स से हमें डील करना होता है सभी क्वेश्चंस में, टाइम एंड डिस्टेंस। और इन दोनों को जब हम साथ में यूज करेंगे तो एक और नया वेरिएबल आएगा जिसे हम कहते हैं स्पीड, राइट। हिंदी में जिसे हम गति कहते हैं, राइट। सो देखते हैं क्या ये वेरिएबल्स हैं जिनसे हमें डील करना है इस टॉपिक के क्वेश्चंस में। तो सबसे पहले टाइम, राइट। टाइम हम जनरली डिनोट करेंगे टी से, राइट। नेक्स्ट डिस्टेंस, जैसे कि आप देख सकते हैं डिस्टेंस को हम डिनोट करेंगे डी से, राइट, स्मॉल डी। और इन दोनों को मिलाकर जो वेरिएबल आएगा उसे हम कहते हैं स्पीड, राइट। स्पीड इज द रेट एट विच द डिस्टेंस इज कवर्ड, राइट। आप किस रेट से दी गई डिस्टेंस को कवर कर रहे हैं उसे हम स्पीड कहते हैं, राइट। सो स्पीड को हम डिनोट करेंगे एस से, स्पीड हम डिनोट करेंगे एस से। तो ये तीन बहुत ही इंपॉर्टेंट टर्म्स और वेरिएबल्स हैं यहाँ पर, राइट। स्पीड, डिस्टेंस और टाइम, राइट। अब इन तीनों के बीच में रिलेशनशिप क्या है? स्पीड, जिसे मैंने बताया, स्पीड इज द रेट एट विच डिस्टेंस इज कवर्ड। आप किस रेट से डिस्टेंस कवर कर रहे हैं, राइट। डिस्टेंस यानी कोई लेंथ, राइट, कोई लेंथ, या जिसे हम हिंदी में दूरी कह सकते हैं, राइट। तो किसी दूरी को आपको कवर करना हो तो आप कितने समय में उसे कवर करेंगे, राइट, किस रेट से कवर करेंगे, उसे हम स्पीड कहते हैं, राइट। सो स्पीड इज इक्वल टू डिस्टेंस बाय टाइम, राइट। ये बहुत ही बेसिक कॉन्सेप्ट है। स्पीड इज इक्वल टू डिस्टेंस बाय टाइम, या फिर हम कह सकते हैं डिस्टेंस ट्रैवल्ड बाय टाइम टेकन टू ट्रैवल द डिस्टेंस, राइट। सो ये है सबसे इंपॉर्टेंट इक्वेशन, स्पीड इज इक्वल टू डिस्टेंस बाय टाइम। तो चाहे कोई भी कॉन्सेप्ट हो, चाहे कोई भी क्वेश्चन हो इस टॉपिक का, बेसिक आइडिया यही रहेगा कि हमेशा स्पीड इज इक्वल टू डिस्टेंस बाय टाइम। अब चाहे वो रिलेटिव स्पीड का कॉन्सेप्ट हो या फिर एवरेज स्पीड का कॉन्सेप्ट हो, हमेशा स्पीड हम डिस्टेंस बाय टाइम ही मेजर करेंगे। तो अगर आप देखें इसे, s इज इक्वल टू डी बाई टी, राइट। ये है सबसे बेसिक फॉर्मूला इस टॉपिक का, राइट। स्पीड इज इक्वल टू डिस्टेंस बाय टाइम, या s इज इक्वल टू डी बाई टी। वैसे अगर आप देखें इस एक इक्वेशन में हमारे पास तीन वेरिएबल्स हैं, s, d और t। यानी इन तीनों में से हमें कोई भी दो दिए जाएंगे और हमें थर्ड वेरिएबल कैलकुलेट करना होगा, राइट। मान ले डिस्टेंस और टाइम दिए गए, राइट, d और t की वैल्यूज दी गई है, हमें स्पीड कैलकुलेट करना है। कैसे करेंगे? s इक्वल्स टू डी बाई टी, राइट। अब इसी फॉर्मूले से आप और भी दो इक्वेशंस फ्रेम कर सकते हैं, राइट। हम कह सकते हैं डिस्टेंस इज इक्वल टू स्पीड इनटू टाइम, डिस्टेंस इज इक्वल टू स्पीड इनटू टाइम, राइट। तो अगर स्पीड और टाइम दिए गए हो, हमें डिस्टेंस कैलकुलेट करना है। कैसे करेंगे? प्रोडक्ट ऑफ स्पीड एंड टाइम, राइट। एंड फाइनली टाइम कैसे कैलकुलेट करेंगे? टाइम विल बी इक्वल टू डिस्टेंस बाय स्पीड, राइट। आप इस इक्वेशन को देखिए, टाइम और स्पीड को हमें इंटरचेंज करना है, राइट। टाइम उधर जाएगा और स्पीड यहां पर डिनोमिनेटर में आएगा। So टाइम इज इक्वल टू डिस्टेंस बाय स्पीड। तो ये दो और इक्वेशन है, या फिर आप फॉर्मूले कह सकते हैं, जो हम इस बेसिक इक्वेशन से डिराइव कर सकते हैं, राइट। वैसे आपको तीनों याद रखने की जरूरत नहीं है, एक ही इक्वेशन, राइट, एक ही फॉर्मूला है। दिखने में आपको तीन अलग अलग इक्वेशन लगेंगे, लेकिन सेम इक्वेशन है। क्या है? स्पीड इज इक्वल टू डिस्टेंस बाय टाइम, राइट। ये बहुत ही इंपॉर्टेंट है, यही इसीलिए हम कह रहे हैं कि स्पीड इज डिस्टेंस ट्रैवल्ड बाय द टाइम टेकन टू ट्रैवल द डिस्टेंस, क्योंकि यहां पर हम देखते हैं कि किस रेट से, राइट, आप स्पीड कवर, डिस्टेंस कवर कर रहे हैं, राइट। तो डिस्टेंस बाय टाइम लेना होगा, स्पीड इज इक्वल टू डिस्टेंस बाय टाइम। अब इन तीनों इक्वेशंस को अगर आप देखें, या फिर इस बेसिक इक्वेशन को देखें, तो हमें ये पता चलेगा कि कैसे ये वेरिएबल्स एक दूसरे से लिंक्ड है, राइट। इनके बीच में रिलेशनशिप क्या है। अगर किसी दो वेरिएबल्स को आपको लेना हो, इनके बीच में कैसी प्रोपोर्शनैलिटी है, डायरेक्ट प्रोपोर्शनल है या फिर इनडायरेक्टली प्रोपोर्शनल है, चलिए वो समझ लेते हैं। तो अगर आप देखें यहां पर, मान ले टाइम कांस्टेंट हो, टाइम कांस्टेंट है यानी टाइम फिक्स्ड है, आपके पास 4 आवर्स है एंड आपको कवर करनी है कुछ डिस्टेंस, राइट। आपके पास 4 आवर्स है, कितनी डिस्टेंस कवर कर सकते हैं। तब क्या होगा? अगर आपकी स्पीड हाई होगी तो डिस्टेंस कवर्ड भी ज्यादा होगी, अगर आपकी स्पीड लो है तो डिस्टेंस कवर्ड कम होगी। क्योंकि अगर आप इस इक्वेशन को देखें, स्पीड और डिस्टेंस एक दूसरे से डायरेक्टली प्रोपोर्शनल है। हम क्या कह रहे हैं? टाइम कांस्टेंट है, टाइम चेंज नहीं हो रहा है, तो डिनोमिनेटर फिक्स्ड है यहां पर। तो अगर आप देखें, स्पीड इज इक्वल टू डिस्टेंस बाय कांस्टेंट, यानी स्पीड और डिस्टेंस दोनों एक दूसरे से डायरेक्टली प्रोपोर्शनल है। हम कह सकते हैं स्पीड इज डायरेक्टली प्रोपोर्शनल टू डिस्टेंस। कब? अगर टाइम कांस्टेंट हो तो। कांस्टेंट का मतलब है टाइम अगर फिक्स्ड हो तो, राइट। तो अगर 4 आवर्स का टाइम दिया जाए, कितनी डिस्टेंस कवर करेंगे आप, ये डिपेंड करता है आपकी स्पीड पर। अगर ज्यादा स्पीड हो तो ज्यादा डिस्टेंस, कम स्पीड हो तो कम डिस्टेंस। जैसा ना, जितनी ज्यादा आपकी स्पीड होगी उतनी ज्यादा डिस्टेंस कवर होगी। जैसे जैसे स्पीड इंक्रीज या डिक्रीज होगी वैसे वैसे डिस्टेंस भी इंक्रीज या डिक्रीज होगी। या कॉन्वर्सली आप कह सकते हैं कि अगर आपको ज्यादा डिस्टेंस कवर करनी हो तो आपकी स्पीड भी ज्यादा होनी चाहिए, अगर कम डिस्टेंस कवर करनी हो तो स्पीड कम होनी चाहिए। तो ये अंडरस्टैंडिंग बहुत इंपॉर्टेंट है अलग अलग वेरिएबल्स के बीच में। तो स्पीड और डिस्टेंस दोनों डायरेक्टली प्रोपोर्शनल है एक दूसरे से अगर टाइम कांस्टेंट हो। सिमिलरली हम देखते हैं कि अगर कोई दूसरा वेरिएबल कांस्टेंट हो तो कैसे इन्हें रिलेट करेंगे। जैसे मान लीजिए डिस्टेंस फिक्स्ड है, डिस्टेंस कांस्टेंट है, राइट, स्पीड और टाइम फिर कैसे चेंज होंगे, राइट। तो क्या होगा, अगर ये फिक्स्ड है, न्यूमरेटर फिक्स्ड है, तो स्पीड विल बी इनवर्सली प्रोपोर्शनल टू टाइम, राइट। देखिए अगर टाइम डिनोमिनेटर में है यहाँ पर और स्पीड उस तरफ न्यूमरेटर में, तो हम कह सकते हैं कि स्पीड इज इनवर्सली प्रोपोर्शनल टू टाइम। कब, अगर डिस्टेंस कांस्टेंट है तो, राइट। अगर डिस्टेंस कांस्टेंट हो तो स्पीड इज इनवर्सली प्रोपोर्शनल टू टाइम। इसका मतलब क्या होगा, आपको फिक्स्ड डिस्टेंस दी गई है, मान ली 10 किलोमीटर की डिस्टेंस है, आपको ये डिस्टेंस कवर करनी है, राइट। अब 10 किलोमीटर अगर डिस्टेंस कवर करनी हो तो कितना टाइम लगेगा, ये डिपेंड करता है स्पीड पर। अगर स्पीड ज्यादा है तो टाइम कम होगा। ध्यान रहे, स्पीड और टाइम इनवर्सली प्रोपोर्शनल है, इनके बीच में डायरेक्ट प्रोपोर्शनलिटी नहीं है। तो स्पीड अगर ज्यादा होती है तो टाइम कम हो जाएगा, राइट। ऑब्वियस ही बात है, राइट, ये बेसिक अंडरस्टैंडिंग। अगर आप हाई स्पीड पर ट्रैवल कर रहे हैं तो कम टाइम में उस डिस्टेंस को कवर कर सकेंगे, जो भी डिस्टेंस आपको कवर करनी हो। अगर लो स्पीड पर हम ट्रैवल कर रहे हो तो ज्यादा टाइम लगेगा, राइट। तो इसका मतलब क्या है, ये दोनों इनवर्स है। जैसे जैसे स्पीड इंक्रीज होगी वैसे टाइम डिक्रीज होगा, और जैसे जैसे स्पीड डिक्रीज होगी टाइम इंक्रीज होगा। तो स्पीड और टाइम इनवर्सली प्रोपोर्शनल है। और जो लास्ट रिलेशनशिप है वो है डिस्टेंस और टाइम के बीच में, राइट। डिस्टेंस और टाइम कैसे एक दूसरे से रिलेट कर सकेंगे हम, अगर स्पीड कांस्टेंट हो, यानी आप फिक्स्ड स्पीड पर ट्रैवल कर रहे हैं, राइट। सो तब क्या होगा, डिस्टेंस विल बी डायरेक्टली प्रोपोर्शनल टू टाइम अगर स्पीड कांस्टेंट है तो। इसे अगर आपको इजीली समझना हो तो आप इस इक्वेशन को देख सकते हैं, सेकंड इक्वेशन। यहां पर स्पीड फिक्स्ड है, ये जो फर्स्ट वेरिएबल है ये फिक्स्ड है, ये चेंज नहीं हो रहा है। तब क्या देखेंगे आप, डिस्टेंस और टाइम दोनों न्यूमरेटर साइड पर है, राइट। तो हम कह सकते हैं कि डायरेक्टली प्रोपोर्शनल है, राइट। सो डिस्टेंस इज इक्वल टू स्पीड इनटू टाइम। यहां पर ये फिक्स्ड है, तो जैसे जैसे डिस्टेंस इंक्रीज होगी वैसे वैसे टाइम इंक्रीज होगा, जैसे जैसे डिस्टेंस डिक्रीज होगी वैसे वैसे टाइम डिक्रीज होगा। इसीलिए डिस्टेंस इज डायरेक्टली प्रोपोर्शनल टू टाइम, राइट। मान ले एग्जांपल के तौर पे कि हम 60 किलोमीटर पर आवर की स्पीड पर ट्रैवल कर रहे हैं, राइट। स्पीड फिक्स्ड है, स्पीड चेंज नहीं होगी, 60 किलोमीटर पर आवर। अब आप कितनी डिस्टेंस कवर कर सकते हैं, राइट, या फिर किसी डिस्टेंस को कवर करने में आपको कितना टाइम लगेगा। कैसे होगा रिलेशनशिप डिस्टेंस और टाइम का, डायरेक्ट रिलेशनशिप है। तो अगर आपकी डिस्टेंस ज्यादा हो, अगर आपको लॉन्ग डिस्टेंस कवर करनी हो तो ज्यादा टाइम लगेगा, राइट, मोर टाइम लगेगा। अगर शॉर्ट डिस्टेंस कवर करनी है तो कम टाइम लगेगा, क्योंकि ये दोनों एक दूसरे से प्रोपोर्शनल है। अगर ये इंक्रीज होती है, डिस्टेंस इंक्रीज होती है, तो टाइम टेकन भी इंक्रीज होगा, क्योंकि स्पीड आपकी फिक्स्ड है, राइट, स्पीड चेंज नहीं हो रही है। और अगर डिस्टेंस कम होती है, शॉर्ट डिस्टेंस है, तो टाइम टेकन कम होगा। तो ये रिलेशनशिप बहुत ही इंपॉर्टेंट है। इनफैक्ट इन्हीं रिलेशनशिप से ये फॉर्मूला डिराइव किया गया, स्पीड इज इक्वल टू डिस्टेंस बाय टाइम। और इसीलिए हम स्पीड कहते हैं कि इट इज द रेट एट विच द डिस्टेंस इज कवर्ड, राइट। आप किस रेट पर, रेट यानी टाइम, बेसिकली रेट हम टाइम से रिलेट कर सकते हैं, राइट, रेट को। सो द रेट एट विच द डिस्टेंस इज कवर्ड, राइट, स्पीड इज इक्वल टू डिस्टेंस बाय टाइम। तो ये इंपॉर्टेंट रिलेशन है, राइट। अगर टाइम फिक्स्ड हो, टाइम कांस्टेंट हो, तो स्पीड इज डायरेक्टली प्रोपोर्शनल टू डिस्टेंस। अगर डिस्टेंस कांस्टेंट हो तो स्पीड इज इनवर्सली प्रोपोर्शनल टू टाइम, और अगर स्पीड कांस्टेंट हो तो डिस्टेंस इज डायरेक्टली प्रोपोर्शनल टू टाइम। और वैसे जो बेसिक इक्वेशन है, जो फंडामेंटल फॉर्मूला है इस टॉपिक का, वो है स्पीड इज इक्वल टू डिस्टेंस बाय टाइम। सो कोई भी दो वेरिएबल्स दिए जाएंगे, आपको वो वैल्यूज सब्स्टिट्यूट करके सही जगह पर जो मिसिंग वेरिएबल, जो थर्ड वेरिएबल है, उसे कैलकुलेट करना होता है। तो ये है स्पीड, डिस्टेंस एंड टाइम, इस टॉपिक का बेसिक इंट्रोडक्शन। तो चलिए अब डिस्कस करते हैं कन्वर्जन ऑफ यूनिट्स के बारे में। टाइम एंड डिस्टेंस एक ऐसा टॉपिक है जहां पर हमें प्रॉपरली यूनिट्स यूज करने होंगे अलग अलग वेरिएबल्स के सही आंसर कैलकुलेट करने के लिए, राइट। जैसे अगर आप इस टॉपिक के बेसिक इक्वेशन को देखें, जो है स्पीड इज इक्वल टू डिस्टेंस बाय टाइम, राइट। हमें पता है स्पीड इज इक्वल टू डिस्टेंस बाय टाइम, डिस्टेंस ट्रैवल्ड बाय टाइम टेकन टू ट्रैवल द डिस्टेंस। अब इन तीनों वेरिएबल्स को अलग अलग यूनिट्स में कैलकुलेट किया जा सकता है, राइट। इन्हें अलग अलग यूनिट्स में मेजर किया जा सकता है। जैसे एग्जांपल अगर आप डिस्टेंस को देखें, डिस्टेंस क्या है, डिस्टेंस यानी दूरी, राइट। अगर हिंदी में आप देखें, दूरी कहते हैं, लेंथ होती है, राइट। डिस्टेंस एक लेंथ है। अब लेंथ को हम कई सारे यूनिट्स में मेजर कर सकते हैं, राइट। लेंथ को किलोमीटर्स में मेजर किया जा सकता है, लेंथ को मीटर्स में मेजर किया जा सकता है, या फिर हम इंचेस में, सेंटीमीटर्स में, मिलीमीटर्स में, राइट, या फिर फीट, यार्ड्स, अलग अलग यूनिट से लेंथ मेजर करने के। तो पॉइंट ये है कि डिस्टेंस को कई सारे यूनिट्स में मेजर किया जा सकता है, लेकिन जनरली हम डिस्टेंस किलोमीटर्स या मीटर्स में मेजर करते हैं, राइट। जो स्टैंडर्ड कन्वेंशन है उसके अकॉर्डिंग डिस्टेंस हमेशा मीटर्स या फिर किलोमीटर्स में मेजर की जाती है, राइट। सो जब भी हम क्वेश्चन सॉल्व करेंगे आप देखेंगे कि डिस्टेंस या तो मीटर्स में दी गई होगी या फिर किलोमीटर्स में, राइट। अब अगर आप नेक्स्ट यूनिट को देखें, टाइम कई यूनिट्स में मेजर किए जा सकते हैं, राइट। जैसे टाइम हम सेकेंड्स में कैलकुलेट कर सकते हैं, टाइम मिनट्स में कैलकुलेट किया जा सकता है, टाइम आवर्स में कैलकुलेट किया जा सकता है, टाइम फिर अगर आप देखें डेज में मेजर कर सकते हैं, राइट। 2 डेज का मतलब क्या है, 2 डेज यानी टाइम पीरियड है, राइट। या फिर टाइम आप वीक्स में, मंथ्स में, ईयर्स में, सेंचुरीज में मेजर किया जा सकता है, राइट। तो टाइम के भी कई यूनिट्स है, लेकिन जो स्टैंडर्ड यूनिट्स है जो हम जनरली यूज करते हैं वो है सेकेंड्स और आवर्स, राइट। या तो हम इसे सेकेंड्स में मेजर करेंगे या फिर आवर्स में, मिनट्स में मेजर कर सकते हैं, एक और यूनिट है मिनट्स, लेकिन जनरली सेकेंड्स एंड आवर्स में मेजर किया जा सकता है। अब क्योंकि डिस्टेंस और टाइम ये दोनों वेरिएबल्स अलग अलग यूनिट्स में मेजर किए जा सकते हैं, इनके थ्रू जो स्पीड आएगी वो भी कई सारे वेरिएबल्स यूनिट्स में मेजर की जा सकेगी, राइट। फॉर एग्जांपल मान ले कि अगर डिस्टेंस मीटर्स में है और टाइम सेकेंड्स में, तो स्पीड क्या होगी, मीटर्स पर सेकेंड, राइट। मीटर्स पर सेकेंड, मीटर्स सो मेनी मीटर्स डिवाइड बाय सो मेनी सेकेंड्स, तो वहां पर हम देखेंगे कि स्पीड मीटर्स पर सेकेंड में होगी। अगर डिस्टेंस मीटर्स में है और टाइम है आवर्स में, तो स्पीड क्या आएगी, मीटर्स पर आवर, राइट। आप कितने मीटर्स कवर कर सकते हैं पर आवर, राइट, एक आवर में, एक घंटे में। सिमिलरली अगर डिस्टेंस किलोमीटर्स में है और टाइम है सेकेंड्स में, तो स्पीड का जो यूनिट होगा, मेजरमेंट यूनिट होगा, वो होगा किलोमीटर्स पर सेकेंड, यानी आप इतने किलोमीटर्स कवर कर सकते हैं पर सेकेंड, एक सेकेंड में। वैसे ही अगर किलोमीटर्स इन आवर्स हैं तो किलोमीटर्स पर आवर। मान लिया अगर डिस्टेंस इंचेस में मेजर की गई हो और टाइम मेजर किया गया सेंचुरीज में, तो स्पीड का यूनिट ऑफ मेजरमेंट क्या होगा, इंचेस पर सेंचुरी। आप इतने इंचेस मेजर कर सकते हैं, इतना इंचेस ट्रैवल कर सकते हैं एक सेंचुरी में, यानी 100 ईयर्स में। तो कई सारे यूनिट्स है जिसमें स्पीड मेजर की जा सकती है अकॉर्डिंग टू यूनिट्स ऑफ डिस्टेंस एंड टाइम। लेकिन फिर से जो स्टैंडर्ड यूनिट्स ऑफ मेजरमेंट है वो बेस्ड होंगे इन यूनिट्स पर, राइट। तो अगर आप डिस्टेंस मीटर्स में ले और टाइम सेकेंड्स में, तो स्पीड आएगी मीटर्स पर सेकेंड, जो कि एक स्टैंडर्ड यूनिट ऑफ मेजरमेंट है, राइट। मीटर्स पर सेकेंड, मीटर्स पर सेकेंड। सिमिलरली अगर डिस्टेंस किलोमीटर्स में ली जाए और टाइम आवर्स में, तो स्पीड को हम मेजर करते हैं किलोमीटर्स पर आवर में, राइट, किलोमीटर्स पर आवर, या फिर इसे आप जनरली kmph भी लिख सकते हैं। तो ये है इंपॉर्टेंट पॉइंट यहां पर कि कैसे अलग अलग वेरिएबल्स मेजर किए जा सकते हैं, राइट। अब इससे भी इंपॉर्टेंट पॉइंट ये है कि कई बार हमें इन यूनिट्स ऑफ मेजरमेंट को कन्वर्ट करना पड़ सकता है क्वेश्चन को करेक्टली सॉल्व करने के लिए, राइट। ध्यान रहे कि जब भी हम टाइम एंड डिस्टेंस के क्वेश्चन सॉल्व कर रहे हैं, यूनिट्स प्रॉपर होने चाहिए, राइट। डिस्टेंस, टाइम और स्पीड, इन तीनों के यूनिट्स एक दूसरे के अकॉर्डिंग होने चाहिए। जैसे कि अगर मान ले हमें पता है स्पीड मीटर्स पर सेकेंड में ही जनरली कैलकुलेट की जाती है या फिर किलोमीटर्स पर आवर में मेजर की जाती है, तो अगर डिस्टेंस मीटर्स में दी गई हो और टाइम आवर्स में दिया गया हो, तो हम डायरेक्टली इन दोनों वैल्यूज को सब्स्टिट्यूट नहीं कर पाएंगे, क्योंकि मीटर्स पर आवर ये एक स्टैंडर्ड यूनिट नहीं है, राइट। अनलेस ऑप्शंस में अगर हमें मीटर्स पर आवर में आंसर दिया गया हो, कोई प्रॉब्लम नहीं, लेकिन अगर ऑप्शंस में किलोमीटर्स पर आवर या फिर मीटर्स पर सेकेंड दिया गया हो, तब हमें कन्वर्ट करना पड़ेगा। क्या कन्वर्ट करेंगे, या तो डिस्टेंस को मीटर से किलोमीटर्स में कन्वर्ट करेंगे या फिर टाइम को आवर से सेकेंड में कन्वर्ट करेंगे, एंड फाइनली आंसर आएगा या तो मीटर्स पर सेकेंड या फिर किलोमीटर्स पर आवर में। तो ये बहुत ही इंपॉर्टेंट पॉइंट है। कई बार क्या होता है स्टूडेंट्स इसे मिस कर जाते हैं, राइट। जो भी वैल्यूज दी गई है डायरेक्टली सब्स्टिट्यूट करके आंसर मार्क करेंगे, जो कि रॉन्ग होगा अगर यूनिट्स प्रॉपर ना हो तो देख लेते हैं कि कैसे हम इन यूनिट्स को इन वेरिएबल्स को एक यूनिट ऑफ मेजरमेंट से दूसरे यूनिट ऑफ मेजरमेंट में कन्वर्ट करते हैं, राइट। सबसे पहले स्टार्ट करेंगे डिस्टेंस से, राइट। डिस्टेंस, अब डिस्टेंस मान लें 1 किलोमीटर है, राइट। 1 किलोमीटर, 1 किलोमीटर यानी 1000 मीटर्स। अब ये सभी स्टैंडर्ड वैल्यूज है, आपको पता होनी चाहिए। 1 किलोमीटर इज इक्वल टू 1000 मीटर्स। तो आप इस एक इक्वेशन को आप यूज करके जो भी डिस्टेंस हो उसे किलोमीटर से मीटर्स में या फिर मीटर से किलोमीटर्स में कन्वर्ट कर सकते हैं। मान लीजिए डिस्टेंस है 3.6 किलोमीटर्स, 3.6 किलोमीटर्स। हम जानते हैं कि 1 किलोमीटर 1000 मीटर्स है, तो 3.6 किलोमीटर्स कितना होगा, 3.6 किलोमीटर्स इन 3.6 इंटू 1000, राइट। 1 किलोमीटर की जगह 1000 मीटर सब्स्टिट्यूट करना है, तो 3.6 इंटू 1000, 3.6 इंटू 1000 होता है 3600। So 3.6 kilometers is equal to 3600 meters. Similarly, अगर मीटर्स से किलोमीटर्स में कन्वर्ट करना हो, राइट, 1000 meters is 1 kilometer, राइट। तो अगर आपको मीटर्स को किलोमीटर्स में कन्वर्ट करना हो तो क्या करेंगे, 1000 से डिवाइड करेंगे, राइट। 1000 मीटर्स है, इसे 1000 से डिवाइड कीजिए, 1 आएगा, 1 किलोमीटर। तो अगर डिस्टेंस दी गई हो मीटर्स में, मान लें डिस्टेंस दी गई है 600 मीटर्स, लेकिन आपको आपकी रिक्वायरमेंट है किलोमीटर्स में, तो कैसे करेंगे, 600 को 1000 से डिवाइड करेंगे, 600 मीटर्स डिवाइड बाय 1000, तो 600 by 1000 कितना होगा, 0.6 किलोमीटर। 600 meters is equals to 0.6 किलोमीटर। तो ऐसे हम डिस्टेंस के यूनिट्स कन्वर्ट कर सकते हैं, राइट, एक यूनिट से दूसरे यूनिट। नेक्स्ट देखते हैं टाइम को कैसे हम कन्वर्ट करेंगे। टाइम जनरली जैसे आप देख रहे हैं यहाँ पर या तो आवर्स में मेजर किया जाएगा या फिर सेकंड्स में। तो 1 आवर इज इक्वल टू कितने मिनट्स होते हैं 1 आवर में? 60 मिनट्स। तो 1 आवर इज इक्वल टू 60 मिनट्स हम लिख सकते हैं, 60 मिनट्स। लेकिन हमें सेकंड्स में चाहिए इसे, राइट। ईच मिनट इज इक्वल टू 60 सेकंड्स। 1 मिनट 60 सेकंड्स होते हैं। तो अगर 60 मिनट्स है तो कितने सेकंड्स होंगे? 60 इंटू 60 अगर आप करें आएगा 3600 सेकंड्स। तो 1 आवर इज इक्वल टू 60 मीटर्स और 3600 सेकंड्स। अब आपको कैसे कन्वर्ट करना है उसके बेसिस पर आप इसे यूज कर सकते हैं। मान ले आपको मिनट्स को आवर्स में कन्वर्ट करना हो, कैसे करेंगे? सी 1 आवर इज 60 मिनट्स, तो 1 मिनट इज इक्वल टू 1/60 आवर्स। जस्ट नो 1 मिनट इज इक्वल टू 60 से डिवाइड करना है दोनों साइड। सो 1/60 आवर्स इज इक्वल टू 1 मिनट। अब मान ले अगर टाइम दिया गया है 45 मिनट्स, 45 मिनट्स को आपको आवर्स में कन्वर्ट करना है। कैसे करेंगे? 45 को हम 60 से डिवाइड करेंगे, राइट, क्योंकि मिनट्स को जब हम 60 से डिवाइड करते हैं नंबर ऑफ आवर्स आ जाएगा। सो 45/60 हो जाएगा 3/4 या 0.75। सो 45 मिनट्स इज इक्वल टू 0.75 आवर्स और 3/4 आवर्स। सिमिलरली आवर्स को अगर मिनट्स में कन्वर्ट करना हो तो 60 से मल्टीप्लाई करेंगे। ये बहुत ही सिंपल कन्वर्जन है, राइट। जैसे 3 आवर्स इज इक्वल टू हाउ मेनी मिनट्स? 3 इंटू 60 मिनट्स, 180 मिनट्स, क्योंकि 1 आवर इज इक्वल टू 60 मिनट्स। सिमिलरली आवर्स टू सेकंड्स भी कन्वर्ट किया जा सकता है, राइट। मान ले दिया जाए 3600 सेकंड्स, 1 आवर। अगर 7200 सेकंड्स दिए गए उसे आवर्स में कन्वर्ट करना हो, सो डिवाइड मल्टीप्लाई बाय 7200 सेकंड्स है, किससे डिवाइड करेंगे? 3600 से डिवाइड करेंगे, क्योंकि 1 आवर में 3600 सेकंड्स होते हैं। तो 7200 सेकंड्स है, 3600 से डिवाइड करेंगे 2 आवर्स आएगा, राइट। तो ऐसे आप कन्वर्ट कर सकेंगे आवर्स को सेकंड्स में और सेकंड्स को आवर्स में। तो बेसिकली इसी एक इक्वेशन यूज करके हम टाइम के यूनिट्स चेंज कर सकते हैं रिक्वायरमेंट के अनुसार। अब मोस्ट इंपॉर्टेंट है कि स्पीड को कैसे कन्वर्ट करेंगे, राइट। कई बार क्या होता है, स्पीड मीटर्स पर सेकंड में दी गई है लेकिन हमें चाहिए किलोमीटर्स पर आवर में, या वाइस वर्सा, किलोमीटर्स पर आवर में दी गई है और रिक्वायरमेंट है मीटर्स पर सेकंड में। तो देखते हैं कि कैसे हम स्पीड को कन्वर्ट करते हैं एक यूनिट से दूसरी यूनिट में, राइट। अब स्पीड जैसे कि स्टैंडर्ड फॉर्मूला है डिस्टेंस बाय टाइम, राइट। मान लेते हैं डिस्टेंस है 1 किलोमीटर, राइट। स्पीड 1 किलोमीटर पर आवर है, 1 किलोमीटर पर आवर, ये है स्पीड, दी गई स्पीड। अब 1 किलोमीटर पर आवर का मतलब क्या होगा? डिस्टेंस 1 किलोमीटर कवर की जा सकती है पर आवर, टाइम 1 आवर में। सो 1 किलोमीटर कवर कर सकते हैं 1 आवर में। सो बेसिकली इसे हम लिख सकेंगे 1 किलोमीटर बाय 1 आवर, राइट। 1 किलोमीटर पर आवर का मतलब। और 1 किलोमीटर अगर मीटर्स में कन्वर्ट करना हो तो 1000 मीटर्स, राइट। एंड 1 आवर को अगर सेकंड में कन्वर्ट करना हो तो 3600 सेकंड्स, राइट। तो अगर आप देखें जो स्पीड 1 किलोमीटर पर आवर थी, अब वो मीटर्स और सेकंड्स के यूनिट्स में आ गई। बस इसे सिंप्लीफाई करना है, राइट। क्या करेंगे? दिस इज 200 इंटू 5 और 200 इंटू 18। सो 1 किलोमीटर पर आवर इज इक्वल टू 5/18 मीटर्स पर सेकेंड, 5/18 मीटर्स पर सेकेंड, राइट। सो ये है कन्वर्जन। 1 किलोमीटर पर आवर होता है 5/18 मीटर्स पर सेकेंड, राइट। या फिर अगर 1 मीटर्स पर 5/18, राइट, 5/18 मीटर्स पर सेकेंड, या फिर 1 मीटर पर सेकेंड को आपको या मीटर्स पर सेकेंड का आपको आवर्स किलोमीटर्स पर आवर में कन्वर्ट करना हो तो इसे दूसरी तरफ ले जाएंगे। सो 1 मीटर पर सेकेंड हो जाएगा 18/5 किलोमीटर पर आवर, राइट। सो आपको ये ध्यान में रखना है 1 किलोमीटर पर आवर इज इक्वल टू 5/18 मीटर्स पर सेकेंड, राइट। और इससे जो दूसरा कन्वर्ट जाएगा वो ये है कि 1 मीटर पर सेकेंड इज इक्वल टू 18/5 किलोमीटर्स पर आवर, 18/5 किलोमीटर्स पर आवर। तो ऐसे आप यूनिट्स कन्वर्ट कर सकते हैं स्पीड के। ये दो स्टैंडर्ड कन्वर्जन है, राइट। किलोमीटर्स पर आवर को मीटर्स पर सेकंड में कन्वर्ट करना एंड मीटर्स पर सेकंड को किलोमीटर्स पर आवर में कन्वर्ट करना। तो अगर आपको किलोमीटर्स पर आवर को मीटर्स पर सेकंड में कन्वर्ट करना हो, जो भी मैग्नीट्यूड हो उसे 5/18 से मल्टीप्लाई करेंगे, और मीटर्स पर सेकंड को किलोमीटर्स पर आवर में कन्वर्ट करना है, जो भी मैग्नीट्यूड दिया गया हो, सो एंड सो x मीटर्स पर सेकंड, उस x को हम 18/5 से मल्टीप्लाई करेंगे, किलोमीटर्स पर आवर में कन्वर्ट करेंगे। तो आपको ये ध्यान में रखना है, राइट, ये याद रखना है आपको कन्वर्जन। एक सिंपल एग्जांपल लेते हैं। मान ले स्पीड दी गई है 90 किलोमीटर पर आवर, राइट। स्पीड है 90 किलोमीटर पर आवर और आपको ये कन्वर्ट करनी है मीटर्स पर सेकंड में। 90 किलोमीटर पर आवर कितने मीटर? कैसे करेंगे? किलोमीटर पर आवर को 5/18 से मल्टीप्लाई करना है। तो जो भी मैग्नीट्यूड है 90 है ना, 90 को हम 5/18 से मल्टीप्लाई करेंगे मीटर्स पर सेकंड में लाने के लिए, राइट। 1 किलोमीटर पर आवर को हमने 5/18 मीटर्स पर सेकंड से कन्वर्ट कर दिया। अब जो भी 90 है वो एज इट इज रहेगा। तो ये क्या होगा? 5 टाइम्स यहाँ पर कैंसिल होता है, 5 इंटू 5 25 meters per second. So 90 kilometers per hour is equal to 25 meters per second. Similarly, दूसरा कन्वर्जन अगर करना हो, speed is equal to, let's say मान ले 20 meters per second, 20 meters per second. इसे हमें कन्वर्ट करना है किलोमीटर्स पर आवर में, कितने किलोमीटर्स पर आवर है। कैसे करेंगे? मीटर्स पर सेकेंड को 5/18 किलोमीटर्स पर आवर से रिप्लेस कर सकते हैं। 1 मीटर पर सेकेंड को 18/5 किलोमीटर्स पर आवर से कन्वर्ट रिप्लेस कर सकते हैं। यहां पर कितने हैं? 20 मीटर्स पर सेकेंड, तो इसे क्या करके 20 इंटू 1 मीटर पर सेकेंड की जगह 18/5 किलोमीटर्स पर आवर। अब इसे सिंप्लीफाई करिए, ये 4 टाइम्स कैंसिल होगा, 4 18 कितना होता है? 72, ये हो जाएगा 72 किलोमीटर्स पर आवर। सो 20 मीटर्स पर सेकेंड इज इक्वल टू 72 किलोमीटर्स पर आवर। तो ऐसे हमें कन्वर्ट करना है। इतने सारे स्टेप्स आपको लिखने नहीं है, अगर आप कैलकुलेशन मेंटली कर सकें तो डायरेक्टली भी कन्वर्ट कर सकते हैं, किलोमीटर्स पर आवर टू मीटर्स पर सेकेंड या फिर मीटर्स पर सेकेंड टू किलोमीटर्स पर आवर। तो बेसिकली पॉइंट यही है कि कई यूनिट्स होते हैं डिस्टेंस को और टाइम को और स्पीड को मेजर करने के, लेकिन जो स्टैंडर्ड यूनिट्स हैं जो जनरली यूज किए जाते हैं डिस्टेंस के लिए किलोमीटर्स और मीटर्स, टाइम के लिए आवर्स और सेकेंड्स, एंड स्पीड के लिए अकॉर्डिंगली आएंगे किलोमीटर्स पर आवर और मीटर्स पर सेकेंड। तो यूनिट्स को प्रॉपर्ली हमें बैलेंस करना होगा हमेशा क्वेश्चंस को सॉल्व करने से पहले, राइट। फाइनल सिंप्लीफिकेशन करने से पहले देखने की यूनिट्स सही है या नहीं, राइट, प्रॉपर है या नहीं। या तो सारे किलोमीटर्स एंड आवर्स एंड किलोमीटर्स पर आवर में होने चाहिए, या फिर मीटर्स सेकेंड्स और मीटर्स पर सेकेंड में होने चाहिए। अगर कोई भी एक ना हो तो उसे अकॉर्डिंगली कन्वर्ट करना होगा इन कन्वर्जन रूल्स के अनुसार।
Let us now take the first model from time and distance, where we shall solve some basic questions on the equation speed equals to distance by time. Let us look at the first example here. The question is, a bus covers a distance of 216 kilometers in 4 hours. What is the speed of the bus in meters per second? So as you can see here, very clearly the distance is 216 kilometers and the time taken is 4 hours. And we are supposed to find out the speed of the bus in meters per second. We know that speed is equal to distance traveled by time taken to travel the distance. So here we can say the speed will be, the distance is 216 kilometers and the time is 4 hours. So here we get the speed in kilometers per hour. So this is 4 into 1 and 4 into 54. So clearly the speed is 54 kilometers per hour. But as given in the question, we are supposed to find out the speed in meters per second. So let us convert this speed of kilometers per hour into meters per second. As we have discussed earlier, 1 kilometer per hour will be equal to 5/18 meters per second. So with the help of this equation, we can convert the speed into meters per second. So whenever we have to convert kilometers per hour to meters per second, we can simply multiply the given value by 5/18 to get the required answer. So this 54 kilometers per hour can be taken as 54 into 5/18 meters per second. Now 18 here goes 3 times. So 3 into 5 is 15 meters per second. So the answer for this question will be 15 meters per second. Let us now take another example from model 1. The question here is, a man walks at the speed of 5 kilometers per hour and runs at the speed of 10 kilometers per hour. How much time will the man require to cover the distance of 28 kilometers if he covers half of his journey walking and half his journey running? So as given in the question, the total distance to be covered is 28 kilometers and the man covers half of his journey, that is first 14 kilometers by walking and the remaining 14 kilometers by running. So we need to find out the total time required by the man. We also know the speed of the man when he is walking, that is 5 kilometers per hour, and his speed while running will be 10 kilometers per hour. Let us see how can we solve this question. We know that speed is equal to distance by time, or from this we can say time is equal to distance by speed. As you can observe here, the total journey is covered into 2 halves. So we can say that there are 2 periods of time. In the first time period, the man walks, and the other time period, the man runs. So the total time required can be taken as time for walking plus time for running. And as we know that time is distance by speed, we can simply say that time for walking is distance which he covers by walking divided by speed of walking, plus again time is nothing but distance by speed. So time for running will be distance that is covered by running and the speed when the man runs. And we have got all these 4 values. So simply by substituting in this equation, we can get the required answer. We know that the distance which the man covers by walking is 14 kilometers. That is nothing but the first half of his journey. So 14 divided by the speed of walking is 5 kilometers per hour divided by 5, plus the distance which he covers by running is the remaining half, that is the other 14 kilometers, divided by the speed while running is 10 kilometers per hour. So this should be divided by 10. If we observe here, the distances are given in kilometers and the speeds are given in kilometers per hour. So obviously the time which we get from this will be in hours. So we need not convert anything here and we can directly proceed for the calculation. So 14 by 5 plus 14 by 10. If you simplify this, 10 is the LCM, 5 goes 2 times. So 2 into 14 plus 10 is 1 time. So 1 into 14. So that is 28 plus 14, 42 by 10. So we can say that the total time required is 4.2 hours. Let us now take an interesting example based on model 1. The question here is, a man takes 6 hours in walking to a certain place and riding back. He would have taken 2 hours less by riding both ways. What will be the time required by him to walk both the ways? The first statement here is, a man takes 6 hours in walking to a certain place and riding back. That means man here is covering a distance between 2 points. So while going from one point to the other, that is while moving from first point to the second point, he walks. But in the return journey, that is from point 2 to point 1, he rides. And the time taken is 6 hours. So we can say that the time taken for walking plus time taken for riding is equal to 6 hours. Remember friends, the distance which is covered while walking and while riding is equal. Why? Because he is moving between the same 2 points. The second statement here is, he would have taken 2 hours less by riding both the ways. So in case if he rides from point 1 to point 2 and rides again from point 2 to point 1, he will take 2 hours less. So very clearly the time taken for riding and again the time taken for riding the same distance will be equal to 2 hours less than the previous time. So earlier he took 6 hours, this time he will take 2 hours less, that is nothing but 4 hours. So we are supposed to find out what will be the time required by him to walk both the ways. Let us see how can we get the answer here. First of all, we know that from this equation, twice the time taken to ride will be equal to 4 hours. So very clearly the time required to ride will be 2 hours. That means if the person rides from one point to the other, the time taken will be 2 hours. So if we substitute this time of 2 hours in the first equation, we can say that time taken to walk plus 2 hours is equal to 6. So from this, the time taken to walk one side of the journey will be 6 minus 2, 4 hours. So as you can see here, from the two equations, we are able to find out the time taken to ride one side of the journey and the time taken to walk one side of the journey. And the question here is, what will be the time required by him to walk both the ways? That means if he is walking both the ways, from point 1 to point 2, he walks, and point 2 to point 1 back again, he walks. So if he is walking both the sides, how much time is required? Very clearly, the time required to walk both the ways should be double of this time. Why? Because this is for one side 4 hours. So for two sides, the time required should be 8 hours. So we can say here that the time taken to walk both the ways, if he walks both ways, will be equal to twice the time taken to walk one side. So 2 into 4, 8 hours. So the answer for this question is 8 hours. Remember friends, strictly speaking, the paperwork is not required. If you have understood the concept here, this question can be answered without writing any of these steps. Why? Because we simply know that to walk and to ride equal parts of journey, the time taken is 6 hours. And to ride both the sides, the time taken is 4 hours, because it is 2 hours less. So for one side of the journey, the time taken to ride will be 2 hours. That is 4 by 2, 2 hours. And if we take these 2 hours in the first case, it is very clear that the time required to walk was 6 minus 2, 4 hours. So for one side, if it is 4 hours, for both the sides, it has to be 8 hours. So try to be smart and answer these type of questions without doing any paperwork. Let us now discuss the second model from time and distance, where the distance traveled in two different cases are equal, but the speeds and the time are varying. Let us look at the first example. A cyclist travels a certain distance in 6 hours at a uniform speed. In the return journey, he increases his speed by 2 kilometers per hour and covers the same distance in 5 hours. What was his speed initially? So as you can see here, initially the cyclist travels a certain distance in 6 hours. So the distance covered is in 6 hours at a uniform speed which has not been specified. In the return journey, he increases his speed by 2 kilometers per hour. So there is an increase in his speed in the return journey and covers the same distance. Remember friends, this is the most important part of the question, that the cyclist is covering the same distance in the return journey. And that is done in 5 hours. So we need to find out the initial speed of the person here. Now as given here, the distance covered in the two cases is equal. So we can say that D1 is equal to D2. That is nothing but the distance in the first case should be equal to distance in the second case. Now we know that distance is nothing but speed into time. So D1 can be taken as S1 into T1 and D2 can be taken as S2 into T2. Where S1 and T1 are the speed and the time initially and S2 and T2 are the speed and the time in the return journey. Now we need to find out what is the value of S1, that is the initial speed of the person. Let us substitute the remaining values and try to get the answer here. So S1 is S1 as it is. Now as given in the question, the distance was covered in 6 hours in the first case. So T1 is nothing but 6 hours, which should be equal to S2 is the speed in the second case. The question says in the return journey, the speed was increased by 2 kilometers per hour. That is nothing but S2 should be equal to initial speed plus 2 kilometers. So this can be taken as S1 plus 2 as the speed has been increased by 2 kilometers per hour. And the distance was covered in 5 hours. So T2 is nothing but 5. So by simplifying this equation, we can find out the initial speed. So here 6S1 is equals to 5S1 plus 2 into 5, 10. So from this we can say that the initial speed 6S1 minus 5S1 should be equal to S1 will be equal to 10, and that is nothing but 10 kilometers per hour. Why? Because the units here mentioned in the question are kilometers per hour. So we can say that the speed that we have obtained is 10 kilometers per hour. So friends, this is how we can solve these type of questions, by simply equating the distance in the two different cases and finding out the required answer. Let us now take the second example from model 2. The question here is, a student walks to school at the rate of 2.5 kilometers per hour and reaches 6 minutes late. Next day, he increases his speed by 2 kilometers per hour and then reaches school 10 minutes early. What is the distance of the school from his home? So as we can see here, there are two cases. In one case, the student walks at the speed of 2.5 kilometers per hour and he is late to his school by 6 minutes. The next day, he increases his speed by 2 kilometers per hour. That means his new speed, the second day, is 4.5 kilometers per hour. 2.5 plus 2. So when he walks at the speed of 4.5 kilometers per hour, he reaches the school 10 minutes early. And we are supposed to find out the distance of the school from his home. Let us assume that the right time to reach the school is T. That means every day the school starts at time T. Let us assume the time taken in the first case is T1 and that in the second case is T2. So as you can see here, in the first case he reached the school 6 minutes late. That means from the time T1, if we subtract 6 minutes, we will get the right time T. So T can be taken as T1 minus 6. And in the second case, when he increases his speed by 2 kilometers per hour, he reaches his school 10 minutes early. That means if the time taken in the second case is T2, to that time T2, if we add 10 minutes, then we get the right time T. Because he has reached early, he is before the right time. So if we take 10 minutes more, we get the right time T. So we can say that the right time T is also T2 plus 10. Right? If you can observe, in the first case, the time taken was T1. So from that, if we subtract 6, because he was 6 minutes late, if we subtract 6, we get the right time T. And in the second case, the time taken was T2. And as the student was 10 minutes early, we are adding 10 minutes here to get the right time T. Now with the help of this equation, we can get the required answer here. We all know that time is nothing but distance by speed. So T1 can be taken as D1 by S1 minus 6 minutes. And T2 can be taken as D2 by S2 plus 10. Now, in both the cases, the student travels from his home to his school. That means very clearly D1 is equal to D2. So let us assume that D1 is equal to D2 and let us take it as D. So we can now substitute D1 as D divided by the speed in the first case is 2.5 minus 6. And in the second case again, distance D2 is nothing but D divided by the speed in the second case is increased by 2 kilometers per hour. That means the second speed here is 2.5 plus 2, 4.5 kilometers per hour plus 10. But friends, if you remember, in the beginning of the session, we have discussed that whenever we solve questions from time and distance, the units have to be balanced on both the sides. So as you can see here, speed on both the sides is in kilometers per hour and time here is in minutes. So this time in minutes has to be converted to hours before we do the calculation. And as discussed, time in minutes can be converted to hours by dividing by 60. So 6 minutes when divided by 60 is converted to hours, and similarly 10 minutes when divided by 60 is converted to hours. Now from this we can say that d by 2.5 minus d by 4.5 should be equal to 10 by 60 plus 6 by 60. So from this we can take d common, and if we take the LCM here, we get 2.5 into 4.5. So 2.5 into 4.5, and in the numerator we have 4.5 minus 2.5, and this side we have 16 by 60. So from this d will be equal to 16 by 60 into, this goes on the other side, so 2.5 into 4.5 divided by 4.5 minus 2.5 is 2. Now by simplifying this equation we can get the distance between the school and the home. So 2 here goes 8 times. 8 into 2.5 is equals to 20. 20 is 3 times in 60, and 3 goes 1.5 times. So we can say that the distance between the home and the school is 1.5 kilometers. The same question here can also be solved with the help of a simple shortcut formula, and that formula here can be taken as the distance will be equal to the difference of the time in the two cases multiplied by speed S1 into speed S2 divided by S1 difference S2. So this is the shortcut formula to solve this question. But remember, this formula is applicable only for these type of questions where two different speeds will result in two different time of reaching the point. The time difference in this case is nothing but 6 plus 10, 16 minutes. Remember friends, the difference should not be taken as 10 minus 6, 4 minutes. Why? Because this is 6 minutes late and 10 minutes early. So because the sign is changing, or because the times are on two opposite sides, the total time difference should be taken as 10 plus 6, 16 minutes. And this can be verified from the traditional solution as well. If you can see here, we have got the total time as 16 minutes but not 4 minutes. So this delta t should be taken as 16 minutes, and S1 and S2 are given in the question. So simply by substituting these values we can get the answer. But again here as well, before you substitute time and speeds, the units have to be balanced. That means this difference of time of 16 minutes should be converted to hours, and then by substitution we can get the correct answer. So as per your convenience, you can either use the shortcut formula or simply follow the concept to get the answer. Let us now take the third module from time and distance, where generally we can solve the question by equating the time in two different cases. Let us look at the example 1 here. Two trains start at the same time from A and B and proceed towards B and A at 36 km per hour and 42 km per hour respectively. When they meet, it is found that one train has moved 48 km more than the other. What is the distance between A and B? So here we are supposed to find out the distance between the 2 points A and B. So as given in the question, there are 2 points, point A and point B, or we can say there are 2 stations, station A and station B. 2 trains start at the same time from these 2 stations and proceed towards each other at 36 and 42 km per hour respectively. For example, one train starts at 36 km per hour from station A and moves towards station B. At the same time, the other train starts from station B and moves towards station A at the speed of 42 km per hour. Now let us assume that this is the path between the 2 points A and B. When the 2 trains are moving in opposite direction, they meet at some point in between. Let us assume that this is the meeting point. And at this meeting point, it is found that one train has moved 48 km more than the other. So let us assume that the distance covered by the first train up to this point is x. So the distance covered by the train B up to that point will be 48 plus x. Why? Because one train has moved 48 kilometers more than the other. So up to meeting point, if the distance of first train which comes from station A is x, then the distance of second train, which is started from station B, should be 48 plus x. We are supposed to find out the total distance between the two stations A and B. Let us assume that the total distance here is D. So as you can see, the total distance can be taken as x plus 48 plus x, or that is nothing but 2x plus 48. One important point that we need to understand to solve these type of questions is, whenever two bodies that start at the same time and move towards each other in the opposite direction, then the time taken by them to reach the meeting point will be same. For example, as in this case, the trains started from A and B at the same time and they started moving towards each other. So when they meet at the meeting point, the time taken by the first train to reach the meeting point will be same as time taken by the second train to reach the meeting point. So very clearly we can say that the time taken by the first train, which started from A up to meeting point, should be equal to the time taken by the second train, which started from B up to meeting point. So these two times are equal. Time we know is nothing but distance by speed. So the distance traveled by the first train from A to meeting point is x, divided by the speed is 36 kilometers per hour, which should be equal to the distance traveled by the train from B to the meeting point is 48 plus x, and the speed here is 42 kilometers per hour. So by simplifying this equation, we can get the value of x. So as you can see here, this is 6 into 6 and 6 into 7. So when we cross multiply, we get 7x equals to 6 into 48 plus 6x. So when 6x is taken on the other side, 7x minus 6x will be equal to x, that is 6 into 48. Now 6 into 48 is 288. So we can say that x will be equal to 288 kilometers. Remember friends, we are taking kilometers because the speeds here are given in terms of kilometers per hour. So whatever distance we get, that should be taken in terms of hours. We have to find out the total distance between the 2 points A and B. So the total distance D can be taken as x plus 48 plus x, or that is nothing but 2x plus 48. So this will be equal to 2 into 288 plus 48. 2 into 288 will be 576. 576 plus 48 will be 624. So the total distance here is 624 kilometers. So this is how we can equate the time taken by the two trains to reach the meeting point and find out the total distance. In some questions, instead of asking the total distance, the distance of the meeting point from station A or station B is asked. So very clearly, the distance of the meeting point from station A is x. So we can stop here itself. There our answer will be 288 kilometers. And if the distance from station B is asked, then the answer will be 48 plus x. So by adding 48 kilometers to 288, we can get the distance from station B to the meeting point. So for any type of question asked here, we can always equate the time taken by the two trains to reach the meeting point and get the required answer. Friends, after understanding the traditional method of solving the problem, let us now look at the smart way of getting the answer for this question. In this method, we get the answer in simple 2 steps without writing any of these steps. Let us understand how to work on that. Here, the speeds of the two trains are 36 kilometers per hour and 42 kilometers per hour respectively. That means the speed of the first train is 36 kilometers per hour. So we can say that in each hour, the first train covers a distance of 36 kilometers and the second train covers a distance of 42 kilometers in each hour. Very clearly, as both the trains have started at the same time, the first train covers 36 kilometers in 1 hour and the second train covers 42 kilometers in 1 hour. So the difference of the distances covered by these two trains in 1 hour will be 6 kilometers. So for every hour, the difference of the distances will be 6 kilometers. Suppose both the trains travel for 2 hours each. We can say that the total difference in the distances covered by the two trains will be 6 plus 6, because 6 kilometers is the first hour difference, 6 kilometers is the second hour difference. So total difference will be 12 kilometers. Similarly, if each of these trains travels for 3 hours each, in each hour we get a difference of 6 kilometers. So the total difference will be 6 into 3, 18 kilometers and so on. So very clearly, for every hour, the difference of their distances increase by 6 kilometers. So with the help of this point, let us now understand both the trains have travelled for how many hours. We know that in each hour, the difference of the distances is 6 kilometers. But as in the given question, the total difference is 48 kilometers. We can say that this has happened over 48 by 6, that is equal to 8 hours. Nothing but in each hour the difference is 6 kilometers. Total difference is 48. So 48 when divided by 6 will give us the number of hours. So now very clear that both the trains have travelled for 8 hours each. Once we have got the total time that each train has travelled for, we can find out the total distance as 8 into 36 plus 8 into 42. Because the first train has travelled for 8 hours. So the distance covered will be 8 into 36 as the speed is 36. And the second train also has travelled for 8 hours. So the distance covered will be 8 into 42 by the second train. And both the distances together will give the total distance. So by taking 8 common here, we get 36 plus 42. And by solving this, 8 into 78 will be equal to 624. So we can say that the total distance here is 624. So friends, this is how we can solve the problem in a smart way without writing all these steps. The only points which we need to look for is the difference of the distances covered by each of the trains in each hour and the total number of hours for which both the trains have travelled. That can be taken as the total difference divided by the difference in each hour. And once we get the time, we can find out the total distance as time into the speed. So try avoiding those lengthy procedures and get the answer in a smart way. Let us now take another interesting example from Model 3. The question here is, a thief spots a policeman 100 meters away and takes to his heels. If the policeman gives a chase immediately, then how far would the thief have run before he is caught? The speeds of the policeman and the thief are 10 kilometers per hour and 8 kilometers per hour respectively. So as given here, a thief spots a policeman 100 meters away and takes to his heels. That means he starts running immediately. And the policeman gives a chase immediately. So as soon as the policeman spots the thief, he also starts chasing the thief there. So the question is, how far will the thief run before he gets caught by the policeman? And the speeds of the policeman and the thief are 10 kilometers per hour and 8 kilometers per hour respectively. So as given in the question, let us assume that the thief is standing at this point and the policeman is 100 meters away. So the distance between the thief and the policeman is 100 meters. Now as soon as the thief spots the policeman, he starts running, right? And he can run at the speed of 8 kilometers per hour. And immediately the policeman starts chasing the thief at the speed of 10 kilometers per hour. So when they are running in the same direction, definitely the thief gets caught at some point because his speed is lesser than the speed of the policeman. So as they are running in the same direction, let us assume that they get caught at this point. So the policeman catches the thief at this point. So we need to find out the distance which the thief has covered before he gets caught by the policeman. So we need to find out the distance between the thief's initial position and the final position where he is caught by the policeman. Now as we can see here, the same point that we have discussed in example 1 is valid. That is nothing but both the persons have started at the same time. So whenever they meet, the time taken for them to reach the meeting point should be same irrespective of their distances covered and their speeds. So nothing but the time taken by the policeman to reach from his initial position to the final position should be same as time taken by the thief to reach from his initial position to the final position. So let us consider that equality of time, that is time taken by policeman should be equal to time taken by thief. Now time is nothing but distance by speed. So time taken by policeman is the distance covered by policeman by the speed of policeman, and time taken by thief is distance covered by thief by the speed of thief. As we have considered here, the distance between the thief's initial position and the final position is d. And we can understand that the total distance covered by the policeman is 100 plus d. Why? Because he has to cover the extra 100 meters and then the d meters which is covered by the thief. So the total distance covered by the policeman is 100 plus d divided by speed of the policeman is 10 equals to the distance covered by the thief is only d. That should be divided by the speed of the thief, 8. Again friends, if you observe, the distance here 100 is in meters and the speeds are in kilometers per hour. But as such, the conversion is not required because anyhow the units are balanced on both the sides. So we need not convert this meters into kilometers or this speed of kilometers per hour into meters per second. Directly we can proceed with the calculation. So here if you try to simplify this, we get 2 into 4 and 2 into 5 is 10 here. And with cross multiplication we can say that 4 into 100 plus 4d should be equal to 5 into d. So very clearly 5d minus 4d, that is d will be equal to 4 into 100, that is 400 meters. So the distance covered by the thief before he gets caught is 400 meters. Remember here we are taking the distance in meters because the distance here 100 is given in meters. So whatever units is given for the distance, same has to be taken for the obtained answer. So the total distance is 400 meters. So this is the distance which is covered by the thief before he gets caught. Suppose if the question says how much distance is covered by the policeman before he catches the thief, then our answer should be 100 plus d. That is nothing but 100 plus 400, 500 meters. So friends, remember that to solve these type of questions where two bodies started at the same time and they meet at a particular point, we can simply equate the time taken by each of the bodies to reach the meeting point and get the desired answer. Let us now take the fourth model from time and distance, which is based on average speed. Average speed is generally required when the speed of a body is consistently varying over the given period of time. Here, the body travels at different speeds for different intervals of time. So to find out a uniform speed throughout the journey, we always calculate the average speed. So let us first understand how to calculate average speed. The first point here is average speed is not the average of speeds. This is very important. Remember, average speed cannot be taken as the average of the given speeds. It should always be calculated as average speed equals to total distance travelled by total time taken to travel the distance. For example, if the speed of the body for a certain journey was 50 kilometers per hour and for the remaining part of the journey it was 60 kilometers per hour. So we cannot say that the average is 50 plus 60 by 2, that is 55 kilometers per hour. Why? Because that's not the way to find out average speed. Average speed in general should always be calculated as total distance travelled by the body by the total time taken to travel the distance. Let us now take an example based on average speed. The question here is a car covers the first 35 kilometers of its journey in 45 minutes and the remaining 69 kilometers in 75 minutes. What is the average speed of the car for the whole journey? So here we need to find out the average speed of the car for the total journey where it has travelled first 35 kilometers in 45 minutes and then next to 69 kilometers in 75 minutes. We very well know that average speed is nothing but total distance travelled by total time taken. Now here as we can see the distance is in two parts, first 35 kilometers and then 69 kilometers. So we can say that it is d1 plus d2, that is the total distance divided by total time t1 plus t2. So t1 is the time taken to travel d1 and t2 is the time taken to travel d2. So let us now substitute these values. The distance d1 is 35 kilometers and d2 is 69 kilometers. So the total distance is 35 plus 69 kilometers divided by the time taken for the first part is 45 minutes and for the second part is 75 minutes. So the total time here is 45 plus 75 minutes. But friends, as I've already mentioned, whenever we solve these questions, the units have to be proper. This calculation gives us the speed in kilometers per minute, which is not a standard unit of measurement. So we should either find out the speed in kilometers per hour or meters per second, and that can be done based on the options given to us. Here, let us understand how to find out the speed in kilometers per hour. So as we can see, the total time here is nothing but 45 plus 75, that is 120 minutes, which is equal to 2 hours. So we can say that the total distance is 35 plus 69, that is 104 kilometers, which has been covered over a time of 2 hours. So now you can see that the distance is in kilometers and time is in hours. So the speed which we get will be in kilometers per hour. So by simplifying this, we get the speed as 52 kilometers per hour. So this is how we can always find out the average speed as total distance travelled by total time taken. Let us now discuss another example from average speed. The question here is Pratibha covers a distance of 24 kilometers at the speed of 8 kilometers per hour and a distance of 18 kilometers at the speed of 9 kilometers per hour. Further, she covers a distance of 12 kilometers at the speed of 3 kilometers per hour. what is her average speed in covering the whole distance. So again here we need to find out the average speed of Pratibha, which she has covered a distance in 3 different parts. So as we can see from this question, the 3 different speeds are 8 kilometers per hour, 9 kilometers per hour and 3 kilometers per hour. So doesn't mean that the average speed will be 8 plus 9 plus 3 by 3. Average speed should not be taken as average of the speeds. It is always calculated as total distance travelled by total time taken. So here, as the distance has been travelled in 3 parts, let us take it as d1 plus d2 plus d3 divided by t1 plus t2 plus t3. So very clearly, d1, d2 and d3 are 24 kilometers, 18 kilometers and 12 kilometers respectively. But the times t1, t2, t3 are not given in the question. So here, we need to find out the time in terms of speed and distance. We very well know that time is nothing but distance travelled by speed. So we can say that t1 is equal to d1 by s1, t2 should be d2 by s2 and t3 should be d3 by s3. So we have got all the values here, d1, d2, d3 and s1, s2, s3. So by substituting in the formula, we can find out the average speed. So d1 here is 24 kilometers plus d2 is 18 kilometers plus d3 is 12 kilometers, whole divided by d1 by s1, that is nothing but the time taken for covering 24 kilometers. So to cover 24 kilometers, the speed was 8 kilometers per hour. So we can say that the time taken will be 24 by 8 plus for the second part of the journey, d2 by s2. d2 is 18 kilometers and the speed is 9. So this can be taken as 18 by 9 plus for the third part of the journey, the time taken will be d3 by s3. So the distance here is 12 kilometers and the speed is 3 kilometers per hour. So this is 12 by 3. Again, as you can see here, the distances are given in kilometers and the speeds are given in kilometers per hour. So we need not convert any of the units here before we do the calculation. And the speed that we obtain will be in kilometers per hour. So by simplifying this, 8 goes 3 times, 9 here goes 2 times and 3 goes 4 times. So the total distance is 24 plus 18, 42, 42 plus 12, 54, 54 kilometers and the total time is 3 plus 2 plus 4. 3 plus 2 is 5, 5 plus 4 is 9. 9 hours and 9 here goes 6 times. So we can say that the average speed of Pratibha was 6 kilometers per hour. So as you can see here, in general, average speed should always be taken as total distance travelled by total time taken. So whenever the times are not given, we can always take it as distance by speed and find out the required answer. Similarly, in some cases, the distances may not be given, but the times are given. So there the distance can be taken as speed into time and then we can find out the required answer. Let us now take the next example from average speed where the distance travelled in both the parts of the journey are equal. Let us look at the question here. Praveen travelled from city A to city B at the speed of 60 kilometers per hour and back from city B to city A via the same route at the speed of 40 kilometers per hour. Find his average speed for the round trip. So here we can see that Praveen first travelled from city A to city B at the speed of 60, then back from city B to city A through the same route at the speed of 40. And we are supposed to find out the average speed for the round trip. That is nothing but A to B and then B to A. As you can see from this question, only the two speeds are given to us. That is, the first speed is 60 kilometers per hour and the second speed is 40 kilometers per hour. Now again, don't find out the average speed as 60 plus 40 by 2, that is 50 kilometers per hour. Why? Because average speed should not be taken as the average of the given speeds. As discussed earlier, average speed is always total distance travelled by total time. And here the total distance has been covered into 2 parts. So let us take it as d1 plus d2 by t1 plus t2, where d1 is the distance covered in the first part of the journey, d2 is the distance covered in the second part of the journey, and t1 and t2 are the times required to cover d1 and d2 respectively. Now an important point to be noted here is, let us assume that these are the two cities, city A and city B, and the distance between these two cities is equal to d. Now as the question says, while moving from city A to city B, Praveen travelled at the speed of 60 kilometers per hour, and while going back from B to A, his speed was 40 kilometers per hour. The important point is, in both the parts of the journey, that is from A to B and back from B to A, the distance covered was equal. That means nothing but d1 is equal to d2 is equal to d. So let us keep this point in mind, that is D1 and D2 both are equal to D, and try to find out the average speed there. Now as given here, the times are not specified, and in the previous example we have seen that time can be taken as distance by speed. So T1 is D1 by S1 and T2 is D2 by S2. As you can see here, the total distance traveled will be D plus D. Why? Because D1 and D2 both are equal to D, divided by D1 by S1, that is nothing but D by S1, plus D2 by S2, that is D by S2. If we simplify this, we can say that average speed will be equal to D plus D, that is 2D by, if we take D common here, we get 1 by S1 plus 1 by S2. So D and D gets cancelled, and now we can simplify this as 2 divided by, if we take S1, S2 as the LCM, we get S2 plus S1. So from this we can say that the average speed now can be taken as 2S1, S2 divided by S1 plus S2. Why? Because S1, S2 goes in the numerator. So here the average speed is equal to 2 into S1 into S2 divided by S1 plus S2. So friends, now we have obtained a shortcut formula to find out the average speed when the distances traveled are equal. So instead of taking the average speed as total distance by total time, whenever you find that the distance traveled in both the parts are equal, you can simply take the average speed as 2S1, S2 by S1 plus S2. And this now, by substituting the values, we get 2 into 60 into 40 divided by 60 plus 40. So which is equal to 2 into 60 into 40 by 100. So as zeros get cancelled, we get 2 into 6, 12, 12 into 4, 48. So 48 kilometers per hour. Why? Because the speeds are already given in kilometers per hour. So the speed obtained will also be in kilometers per hour. So this is the average speed of Praveen for the round trip from city A to city B and back from city B to city A. Remember friends, for this question, definitely one of the options will be given as 50 kilometers per hour. Why? Because the average of 60 and 40 is 50 kilometers per hour. But as I've already mentioned, the average speed should not be taken as average of the given speeds. So don't get fooled and mark your answer as 50. The answer here is 48 kilometers per hour. Let us now discuss another special case from average speed where the total distance is covered in two equal time intervals at different speeds. Let us look at the question here. Anirudh covered a certain distance in 4 hours where he travelled at the speed of 48 kilometers per hour for the first 2 hours and 60 kilometers per hour for the next 2 hours. Find his average speed for the total journey. So as you can see here, Anirudh has covered the total distance in 4 hours where his speed was 48 kilometers per hour for the first half of the time and then 60 kilometers per hour for the remaining 2 hours, that is the next half of the time. And we have to find out the average speed for Anirudh. Now as already discussed, average speed in general is total distance by total time. So here it can be taken as D1 plus D2 divided by T1 plus T2. Why? Because the distance here has been covered into 2 parts. Now times are already mentioned. T1 is equal to 2 hours and T2 is also equal to 2 hours. But the distance has not been specified. So let us try to substitute the distance in terms of speed and time. We know that distance is equal to speed into time. So D1 here will be equal to S1 into T1 and D2 will be equal to S2 into T2. So we can say that the average speed will be S1 T1 plus S2 T2 divided by T1 plus T2. But as given in the question, both the time intervals T1 and T2 are equal. So let us assume that T1 is equal to T2 is equal to T. And now substitute this in the average speed equation. So we get S1T plus S2T divided by T plus T. So by taking T common, we have S1 plus S2 divided by 2T. And as T gets cancelled here, we can say that average speed will be equal to S1 plus S2 by 2. So again now we have obtained a shortcut formula for this special case where the average speed can be taken as S1 plus S2 by 2. That is nothing but the average of the speeds. But then this is applicable only when the 2 time intervals are equal. So we can now substitute the values of S1 and S2 and get the answer here. So average speed will be S1, that is 48 kilometers per hour, plus S2 60 kilometers per hour divided by 2. So the average of 48 and 60 comes out to be 54. So we can say that the average speed of Anirudh for the total distance was 54 kilometers per hour. So in general, average speed is total distance by total time, but only when we find that the time intervals are equal, we can take it as average of the given speeds. Before we go for the next model, let us quickly revise the various concepts from average speed. Now, as discussed earlier, average speed in general is total distance by total time. There is nothing but d1 plus d2 plus d3 and so on divided by t1 plus t2 plus t3, so on. But there are some special cases. For example, in some cases, average speed can be directly taken as 2s1 s2 by s1 plus s2, where s1 and s2 are nothing but the given speeds. And this is applicable only when d1 is equal to d2. So here we have a shortcut formula for average speed, and the condition is d1 should be equal to d2. Similarly, we have another special case where the average speed can be directly taken as average of the speeds, or s1 plus s2 by 2, where s1 and s2 again are the two given speeds. But this shortcut formula is applicable if and only if the times are equal. That is, the distance is covered in two equal time intervals. So friends, in general, always the average speed can be taken as total distance by total time. But if the total distance has been covered in two equal parts, that is d1 equals to d2, then we can take it as 2s1 s2 by s1 plus s2. And if the total distance is covered in two equal time intervals, that is t1 equals to t2, then the average speed can be taken as s1 plus s2 by 2. So based on the given question, you can use any of these three formulae to get the required answer. Let us now discuss a typical model from time and distance which can be solved with the help of a simple shortcut formula. Let us look at the point first. If two vehicles start at the same time from 2 points A and B and proceed towards each other such that after crossing each other they take time t1 and t2 to reach the points B and A respectively, then the speed of the first vehicle s1 divided by speed of second vehicle s2 will be equal to root over t2 by t1, where t1 is the time taken by first vehicle to reach point B after crossing the second vehicle, and t2 is the time taken by second vehicle to reach point A after crossing the first vehicle. So if two vehicles start at the same time, let us assume these are the 2 points A and B, and two vehicles start from these 2 points A and B. This is the first vehicle starting from point A, and second vehicle starts at the same time from point B. The speed of the first vehicle is s1 and that of the second vehicle is s2. So they are proceeding towards each other. That means they are moving in the opposite direction. So definitely they will cross each other at some point. Let us assume that this is the path and this is the crossing point. So after crossing at this point, the first vehicle takes time t1 to reach its destination B, and the second vehicle takes time t2 to reach its destination A. So in this case, we can say that s1 by s2 should be equal to root over t2 by t1. So t2 is the time taken by second vehicle to reach its destination A from the crossing point, and t1 is the time taken by first vehicle to reach its destination B from again the crossing point. So understand friends, t1 and t2 are not the total times from point A to point B and point B to point A. t1 and t2 are the times required by these two vehicles to reach their destinations from the crossing point. Let us now take an example from model 5 that we have just discussed. The question here is, two trains start from two stations A and B at the same time and proceed towards each other to reach B and A respectively. After crossing each other, they take 36 and 49 hours respectively to reach their destinations. Find the speed of the second train if the first train runs at 140 kilometers per hour. So as you can see here, this question is quite in line with the model that we have discussed. Here we have got two trains which start from 2 points A and B and they proceed towards each other, and their destinations are B and A respectively. After crossing, they take 36 and 49 hours to reach their destinations. So we need to find out the speed of second train, and the speed of first train is given as 140 kilometers per hour. So as discussed, the shortcut formula to get the answer here is s1 by s2 should be equal to root over t2 by t1, where s1 and s2 are the speeds of first and second trains respectively, and t2 and t1 are the times taken by second and the first train to reach their destinations after crossing each other. So let us substitute the given values and find out the required answer. So as given in the question, speed of the first train is 140 kilometers per hour. So 140 by s2 should be calculated. This should be equal to root over time taken by second train is 49. And time taken by the first train to reach its destination is 36 hours. So this can be taken as 140 by S2 equals to 7 by 6. because root over 49 is 7 and root over 36 is 6. Now 7 here goes 20 times, so we can say that S2 will be equal to 20 into 6, 120, and this should be in kilometers per hour because the speed of the first train is given in kilometers per hour. So this is how we can solve these type of questions simply with the help of the shortcut formula, that is S1 by S2 equals to root over T2 by T1. So whenever a question is given in this format, simply use the formula and get the required answer. Let us now take the sixth model from time and distance, where we shall discuss another typical question from this topic, where we have to find out the stoppage time of a vehicle. Let us look at the concept first. Excluding the stoppages, the speed of a vehicle is SE, and including the stoppages, the speed is SI. Then the stoppage time is given as SE minus SI by SE. So here, as you can see, we can take the stoppage time directly as the speed excluding the stoppages minus speed including the stoppages divided by speed excluding the stoppages. So with the help of this simple formula, we can find out the stoppage time directly without writing any further steps. Let's look at an example here. Excluding the stoppages, the speed of a bus is 64 kilometers per hour, and including the stoppages, its speed is 48 kilometers per hour. So for how many minutes does the bus stop per hour? So here, as you can see, we need to find out the number of minutes for which the bus stops per hour. Now, as given in the question, excluding the stoppages, the speed is 64 kilometers per hour. That means when the bus runs non-stop without stopping at any places, the speed is 64 kilometers per hour. Remember, in general, when we say speed here, it is average speed of the bus. So average speed of the bus is 64 kilometers per hour without stopping at any place. And including the stoppages, its speed is 48 kilometers per hour. So when the bus stops at different places per hour, it can cover only 48 kilometers. So we can say that its speed is 48 kilometers per hour on an average. So we need to now find out for how many minutes does the bus stop per hour. Now, as given in the formula here, stoppage time can be taken as the speed excluding stoppages minus speed including stoppages divided by speed excluding stoppages. So speed excluding stoppages is 64 minus speed including stoppages is 48 divided by speed excluding stoppages is 64 again. So this comes out to be 64 minus 48, 16 by 64, which is 1 by 4. So here very clearly the stoppage time is 1 by 4. Now because the speed is given in kilometers per hour, this is 1/4 of an hour or 1 by 4 hours. So we can say that the stoppage time is 1 by 4 hours. But as the question says, for how many minutes does the bus stop per hour, let us now convert this hours into minutes. We have learned in the beginning of this session that to convert hours into minutes, we need to multiply the magnitude with 60. Why? Because each hour has got 60 minutes. So 1/4 of an hour can be taken as 1 by 4 into 60 minutes. And 4 here goes 15 times. So we can say that the bus stops for 15 minutes every hour. So friends, this is how we can solve this simple question with the help of the direct shortcut formula here. So remember, stoppage time is always speed excluding stoppages minus speed including stoppages by speed excluding stoppages. Let us now discuss one very important concept from time and distance, which is called as relative speed. The concept of relative speed is very important in solving various types of questions from time and distance. So let us first understand what is meant by relative speed. Relative speed is defined as speed of one body with respect to another body. So whenever two bodies are moving at the same time, then this concept of relative speed comes into picture. Let us assume that you are sitting in a train which is running at the speed of 80 kilometers per hour. If there is another train which is also running at the same speed, that is 80 kilometers per hour, in the same direction parallel to your train, then you find that the other train appears to be stationary with respect to your train. So we can say that the speed of the second train with respect to your train is 0 kilometers per hour. So this speed of 0 kilometers per hour, that is because of the other train appearing to be stationary, is referred to as relative speed. Actually speaking, the other train is also running at the speed of 80 kilometers per hour. But from an observer's point of view who is sitting in the first train, the second train appears to be stationary. So that is what is called as relative speed. Now there are two possible cases for relative speed. One is relative speed when the two bodies are running in opposite direction, and the second one is relative speed when both the bodies are moving in the same direction. So let us understand how to calculate relative speed in these two cases. Now case 1 here is when two bodies are running in opposite direction with speeds s1 and s2 respectively, then the relative speed is equal to S1 plus S2. That is nothing but the sum of the speeds. And the case 2 here is when the two bodies are running in same direction. So when two bodies are running in same direction with the speeds S1 and S2 respectively, then the relative speed is equal to S1 difference S2. That is nothing but the difference of the speeds. So very clearly the one point which we need to understand here is whenever two bodies are running in opposite direction, the relative speed is sum of the speeds. And whenever two bodies run in the same direction, then their relative speed is the difference of their speeds. The simple point here is when two bodies running in same direction, the relative speed there should be taken as the difference of their speeds. And when two bodies run in the opposite direction, there the relative speed should be taken as the sum of their speeds. For example, let us assume that two trains are running in opposite directions on two different tracks with the speeds of 40 kilometers per hour and 60 kilometers per hour respectively. So the relative speed of one train with respect to the other train is given as sum of their speeds because they are moving in opposite direction. So we can say that the relative speed will be 40 plus 60, that is 100 kilometers per hour. Similarly, if these two trains run in the same direction, that is one train runs at 60 kilometers per hour and the other train is running at 40 kilometers per hour in the same direction, then the relative speed here can be taken as difference of their speeds. That is nothing but 60 difference 40, which is 20 kilometers per hour. So this is how when two bodies run at the same time, either in opposite directions or same directions, we always need to consider the relative speed but not their individual speeds. Let us now take an example based on the concept of relative speed. The question here is two cars starting from the same point and moving in opposite directions will be 227.5 kilometers apart in 3 hours 15 minutes. Had they been traveling in the same direction, they would have been 32.5 kilometers apart in the same time. Find the speed of both the cars. So here we are supposed to find out the speed of both the cars. Now as given the question, they have started from the same point and were moving in the opposite directions. So very clearly, suppose two cars when they start from the same point and move in opposite directions. Let us assume this is the starting point, and when the cars move in opposite directions, they will be 227.5 kilometers apart in 3 hours 15 minutes. So the distance covered by both the cars together is 227.5 kilometers in a time of 3 hours and 15 minutes. But when they travel in the same direction, they would have been 32.5 kilometers apart in the same time. So from the same point, if they travel in the same direction, they would have been only 32.5 kilometers apart in the same time. That is nothing but 3 hours and 15 minutes. So from this data, we are supposed to find out the speed of both the cars. Let us first convert this time of 3 hours 15 minutes into a proper unit, that is completely into hours. We know that 15 minutes is nothing but 1/4 of an hour, and 1/4 of an hour can be taken as 0.25 hours. So this 3 hours and 1/4 of an hour will altogether become 3.25 hours. And even in the second case, the time will be 3.25 hours. Now let us see how can we find out speed of both the cars. Now very clearly, when the two bodies are moving in opposite direction, relative speed should be taken as S1 plus S2. And we know that when they move in the same direction, the relative speed should be taken as S1 difference S2 or S1 minus S2. So let us use this concept of relative speed in finding out the answer here. We know that the general equation is speed is equal to distance by time. So when the two bodies are moving in opposite direction, the relative speed is nothing but S1 plus S2. So we can say S1 plus S2 equals to distance by time. The distance is 227.5 kilometers divided by the time is 3.25 hours. And when they move in the same direction, the relative speed is S1 difference S2. See, generally we take difference because we need to have a positive relative speed. So here let us assume that the first car is running at a higher speed. So we can take it as S1 minus S2, and that should be equal to distance by time. So the distance is 32.5 kilometers and the time taken is 3.25 hours. Here again conversions are not required. Why? Because the distance is given in kilometers and the time is given in hours. So the speeds what we get will be in kilometers per hour. Now let us try to simplify this. This 3.25 goes 70 times in 227.5 and 3.25 goes 10 times in 32.5. So we can say that S1 plus S2 equals to 70, and from the second case we can say that S1 minus S2 equals to 10. Now if we try to solve both the equations which have got two variables, we will get the individual speeds. Let us first add both the equations. So So S1 plus S1 gives 2S1 plus S2 and minus S2 gets cancelled, and 70 plus 10 will be equals to 80. So very clearly the speed of first car will be 80 by 2, that is 40 kilometers per hour, because the time is given in hours and the distance is given in kilometers. Now if the speed of first car is 40 kilometers, we know that sum of their speeds is 70. So it is obvious that the speed of second car should be 30. Why? Because 40 and 30 together make 70. Or from the difference equation we can say that the speed of second car should be 30, because 40 minus 30 will be equal to 10. So the speed of second car equals to 30 kilometers per hour. So these are the speeds of both the cars. So friends, this is how we can use the concept of relative speed in solving questions where two bodies are moving at the same time in opposite direction or same direction. Let us now discuss the 8th model from time and distance, where we are supposed to solve questions related to two trains either moving in opposite direction or moving in same direction. Let us first understand the basic equation that can be used for solving these type of questions. Here there are two possible cases, either two trains move in opposite direction or two trains move in the same direction. Let us look at the first point. When two trains of lengths L1 and L2 are running in opposite direction at speeds S1 and S2 respectively, then the equation which you are supposed to use is S1 plus S2 equals to L1 plus L2 by T, where T is the time taken to cross each other. Now if you observe, this equation is in the form of speed equals to distance by time. We are taking the speed as S1 plus S2 because the two trains are running in opposite direction. And we very clearly know that whenever two bodies run in opposite direction, the relative speed has to be considered. And for opposite direction, the relative speed is sum of the speeds. So that is the reason we are taking S1 plus S2. This distance to be travelled is nothing but sum of their lengths, that is L1 plus L2 divided by time. So this is the basic equation when two trains are running in opposite direction. That is S1 plus S2 equals to L1 plus L2 by T, where S1, S2, L1 and L2 are the speeds and lengths of the first and the second trains respectively, and T is the time taken by the two trains to cross each other. So with the help of this equation, we can find out any one of these 5 variables when the remaining 4 variables are given to us. Similarly, let us now understand the equation to be used when the two trains are moving in same direction. Now here, when two trains of length L1 and L2 are running in same direction at the speeds S1 and S2 respectively, where S1 is greater than S2, then S1 minus S2 equals to L1 plus L2 by T is the equation to be used. And T here is nothing but the time taken by the faster train, which is running at the speed S1, to pass or overtake the slower train. So as you can see here, even this equation is in the form of speed equals to distance by time. That is the basic relationship between speed, distance and time. Here we are taking the speed as S1 minus S2 because the two trains are running in same direction. We know that whenever two bodies run in same direction, the relative speed should be considered, which is the difference of their speeds. And the distance to be covered by both the trains together is again L1 plus L2, which is same as the previous case. And T is the time taken by the faster train to overtake or to pass the slower train. So with the help of these two equations, we can solve the questions related to the two trains moving in opposite direction or same direction. As you can see here, in both the equations, we have got 5 variables, S1, S2, L1, L2 and T. Out of these 5 variables, any 4 will be given in the question. So we are simply supposed to substitute the values at the right places and find out the 5th one. Remember, before we do the calculation to find out the 5th variable, we are supposed to balance the units on both the sides. That is either completely in terms of kilometers per hour or in terms of meters per second. In some special cases, a moving train may have to cross a train which is stationary. So in that case, we can assume that the length of the moving train is L1 and the length of the stationary train is L2. Now the equation to be used there will also be any one of these two. Why? Because the speed of the second train is 0. So we simply can say that S1 plus 0 or S1 minus 0 should be equal to L1 plus L2 by T. So that's how, depending on the speeds of the trains, we can substitute the values and get the answer. Let us now take an example based on the concept where we are supposed to solve questions related to two trains either moving in opposite direction or in the same direction. The question here is, a 270-meter long train running at the speed of 120 kilometers per hour crosses another train running at the speed of 80 kilometers per hour in 9 seconds. What is the length of the other train? So as you can see here, the length of the first train is 270 meters and it is running at the speed of 120 kilometers per hour, and it crosses another train running at the speed of 80 kilometers per hour in 9 seconds. So very clearly we know the speed of the first train, that is 120 kmph, speed of second train 80 kmph. The length of the first train is 270 meters and the time taken to cross is 9 seconds. We are supposed to find out the length of the other train. Now, as we have already discussed, the equations to be used for solving these type of questions are S1 plus or minus S2 equals to L1 plus L2 by T. So the first case here is S1 plus S2 equals to L1 plus L2 by T, and the second case is S1 minus S2 equals to L1 plus L2 by T. So plus is used when the two trains run in opposite direction and minus is used when the two trains run in the same direction. So before we find out the answer, we first need to decide whether we have to use plus or minus. Now as you can see here in the question, nowhere it has been specified whether the two trains are running in opposite direction or in same direction. But one important point given in the question here is that the first train crosses another train in 9 seconds. Now the word crosses here plays an important role. Understand friends, crossing is possible only when the two trains are running in opposite direction. So instead of directly saying that the two trains are running in opposite direction, the question says they are crossing each other. So it is clear that the trains are running in opposite direction. So remember, whenever the word cross is used, we always take the equation of opposite directions. And for same direction, the wording may be overtake or pass. Why? Because overtaking is possible only when the two bodies are running in same direction. Or in general, it can also be referred to as pass. So depending on these words, we need to decide whether the two trains are running in opposite direction or in same direction. Now here it is clear that the two trains are running in opposite direction. So we can say S1 plus S2 should be equal to L1 plus L2 by T. So let us now substitute the values and try to get the required answer. So the speed of the first train here is 120 kilometers per hour and the speed of second train is 80. So 120 plus 80, this is in kilometers per hour, should be equal to L1, the length of first train is 270 meters plus the length of second train is to be calculated. So let us take it as L2 itself, and the time taken to cross the second train here is 9 seconds. Now as you can see here, 4 variables have been given and we are supposed to calculate the fifth one. But as mentioned always, we need to balance the units. Here on the left hand side we have kilometers per hour and on the right hand side we have meters and seconds. So before we do the calculation, we need to convert this into meters per second. So let us convert this speed of kilometers per hour into meters per second. So 120 plus 80, this is 200. 200 kilometers per hour can be converted into meters per second with the help of 5 by 18. So when you multiply this value with 5 by 18, it gets converted to meters per second. So now the speed here is in meters per second. And this is 270 plus L2 divided by 9. Even this side, we have got the units in meters and seconds. So the units have been balanced. And now we can go for the calculation here. So if we try to see here, 9 gets cancelled 2 times. 2 goes 100 times. And 100 into 5 is 500. So we can say 500 is equals to 270 plus L2. So very clearly from this, the length of the second train is 500 minus 270. That is equal to 230 meters. So friends, to solve these type of questions, we simply need to decide which of the two equations have to be used, substitute the values at the right places, balance the units, and find out the required answer. Let us now take the next model from time and distance, which is again based on the concept of relative speed. Here, a train of a given length has to cross another stationary body of some considerable length. Let us understand the equation first. When a train of length LT running at the speed st crosses some stationary body, that is, the speed of the body is 0 as it is a stationary body, of considerable length LB, for example, platform, bridge, tunnel, stationary train, etc. So if you understand, in all these cases, that is for a platform the speed is 0 but it has got a considerable length, that is LB. Or for a bridge or tunnel again the speed is 0. Why? Because all these are stationary objects but they have got some considerable length LB. And even in case of a stationary train, as it is stationary, its speed is 0 and its length is LB. So in such cases, the equation to be used will be ST equals to LT plus LB by T, where ST is the speed of the train, LT is the length of the train, plus LB is the length of the body, that is a platform or bridge or tunnel, etc. and T is the time. And this time is nothing but time taken by the train to cross the stationary body. So we find here that there are 4 variables, ST, LT, LB and T. So out of these 4 variables, any 3 will be given in the question and we are supposed to find out the 4th one. What we need to do here is simply substitute the values at the proper places, balance the equation and do the calculation to get the required answer. Remember friends, if you try to observe, this equation is no way different from what we had discussed in the earlier case. In the earlier case, we have discussed that S1 plus or minus S2 should be equal to L1 plus L2 by T. So if you try to compare with this equation, the only difference is the speed of the second body in this case is 0. For example, for all these bodies, the speed is 0 as they are stationary objects. So this portion of the equation should be taken as 0 and remaining everything else has been taken in the given equation. So S1 is nothing but speed of the first body, that is nothing but the train here. L1 is the length of the train, L2 is the length of the second body and T is the time taken. Let us now take an example based on the model that we have just discussed, where a train of a given length has to cross a stationary body of some length. Let us look at the example here. A goods train runs at the speed of 72 km per hour and crosses a 250 meter long platform in 26 seconds. What is the length of the train? So as you can see here, there is a goods train which runs at the speed of 72 km per hour and it crosses a 250 meter long platform. So platform here has got a length of 250 meter and it's a stationary body, that is the speed is 0 in 26 seconds. So the time taken to cross the platform is 26 seconds. So from this data we are supposed to find out the length of the train. Now we know that the equation to be used here is speed of the train should be equal to length of the train plus length of the other body divided by the time. So by substituting the values here, we can get the required answer. We know that the speed of the train is 72 km per hour, which should be equal to the length of the train, which has to be calculated. So let us take it as LT plus the length of the other body here, that is nothing but the platform is 250 meters divided by the time taken is 26 seconds. So this is 250 meters and 26 seconds. So now by simplifying this equation, we can find out the length of the train. But as you can see here, the speed is in kilometers per hour and the length and time given is in meters and seconds respectively. So we first need to balance the units. So for that, we can convert this kilometers per hour to meters per second. So this can be taken as 72 into 5 by 18. So now this is in meters per second, which is equal to length of the train plus 250 divided by 26. So the equation now is completely balanced into meters per second. Now by simplifying this, we can say 18 into 1 and 18 into 4 is 72. 4 into 5 is 20. 20 into 26 will be equal to length of the train plus 250. So from this, the length of the train will be 20 into 26 is 520 and 520 minus 250 will give 270. So the length of the train should be 270 meters. So as simple as that, we just need to take the proper equation, substitute the values, balance the units and then do the calculation to get the required answer.
Hi guys, welcome to TalentSprint. Let's look at the example. A train of length 300 meters can cross a pole in 8 seconds. How long will it take to cross a platform of length 600 meters? Now I'm sure the regular way of solving this question involves finding out the speed of the train first, because we know what distance the train covers in 8 seconds, and then with that speed and the length of the platform we try to find out the new time, and it takes a bit of time, about 15 to 20 seconds in getting the final answer for this question. But as I've mentioned earlier, if you use common sense as against the conceptual approach, you will be able to mark the answer for this question much faster. So let's look at how do we answer this just through common sense.
See, if you observe, the train of length 300 meters can cross a pole in 8 seconds. This means that it takes 8 seconds for the train to cover a distance of 300 meters, right? We all know that crossing a pole involves to cover its own length, right? So here clearly the train takes 8 seconds to cover a distance of 300 meters, right? Now in the next part of the question we need to find out how long will it take to cross a platform of length 600 meters. Now understand, when the train has to cross the platform, how much does it have to travel? It has to travel its own length plus the length of the platform. Now what is the length of the train? 300 meters, and the length of the platform here is given as 600, which means in the second case the train has to cover total 300 meters plus 600, that is 900 meters, alright. This is 900 meters. We very well know that the time required is proportional to distance. The speed is constant here, right? It is the same train. So the time required would be proportional to distance. More the distance, more the time required, right? So if 300 meters take 8 seconds, 900 meters would take how many seconds? 8 into 3, that is 24 seconds. So we can say that the answer for this question is 24 seconds, right? The simple point here is time is proportional to distance. So 300 meters can be covered in 8 seconds. 900 meters is 3 times this distance, right? 3 into 300 is 900. So 3 into 8, 24 seconds is your answer. So avoid the conventional method which involves finding the speed of the train first and then the time required to cross the platform. Instead, keep it simple, get your common sense back and answer this question in about 3 seconds.
Let us now take the next model from time and distance, which is based on boats and streams. Now in this particular case, we have a stream or nothing but a flowing river, and in which a boat has to cover a certain distance. Let us understand what are the different cases when it comes to boats and streams. As you can see here, we have a river which is flowing at a certain speed, that is SS. It is nothing but the speed of the stream, or it can also be called as the speed of the current. A stream or current is nothing but flowing water, and whenever the water is flowing, it has some speed which is taken as SS. Let us consider a boat here in this river which has to cover a certain distance. Now here the boat can move in two possible directions. Either it can go against the flow of the stream, which is referred as upstream, or along with the flow of the stream, that is downstream. So upstream is nothing but opposite to the stream, and downstream is nothing but in the same direction of the stream. So let us take what are the various possible cases in case of boats and streams here. Now as given here, the speed of the stream or the current, or it can also be called as speed of the river, is equal to SS. The speed of the boat in still water is SB. That means when this boat is kept in still water, nothing but a lake, then it can be moving at a speed of SB. So here we can say that the speed of the boat along the stream is nothing but downstream. So speed of the boat along the stream should be taken as SB plus SS. So downstream speed SD is equal to SB plus SS. That is nothing but speed of the boat plus speed of the stream. And the speed of the boat against the stream or upstream. When the boat is going against the stream, it is referred as upstream. So speed of the boat upstream, that is SU, should be taken as SB minus SS. So speed of the boat minus speed of the stream will give the speed upstream. So the two important points here are downstream speed and upstream speed. As you can see here, downstream speed is equal to SB plus SS, that is sum of the speeds of boat and the stream. And upstream speed is the difference here, that is boat speed minus the stream speed. After taking the downstream speed and upstream speed, let us now see how can we find out the speed of the boat and the speed of the stream when SD and SU, that is downstream and upstream speeds, are given to us. So the speed of the boat here can be directly taken as downstream speed plus upstream speed divided by 2. So in some cases, when the downstream and upstream speeds are specified, we can take the speed of the boat as SD plus SU by 2. And similarly, the speed of the stream or the current can be taken as SD minus SU by 2. So speed of the stream is equal to downstream speed minus upstream speed by 2. Remember friends, in some cases, instead of boat, the question is regarding a man who is swimming in the river. So that can again be considered in the same way. Nothing but we need to just replace the speed of the boat with the speed of the man in still water. So equations and all remain same. The only difference is instead of a boat, we have a man who can either swim upstream or he can swim downstream. So whether the question is related to boat which can row upstream or downstream, or a man who can swim upstream or downstream, the equation remains same. Before we take up some examples, let me draw your attention to one very important point here, so that there is no confusion while solving the questions. If you observe, when the boat is going upstream, the direction of flow of water and the direction of flow of boat is opposite to each other. Now in the previous cases, we have learned that whenever two bodies are moving in opposite direction, the relative speed should be taken as sum of the speeds. But in this case, when the boat is moving upstream, that is against the flow of water or in the opposite direction of flow of water, we have taken the speed as the difference of the speeds, which is quite opposite to the relative speed case. And similarly, when the boat is going downstream, that is when the direction of flow of water and the direction of boat are same, here we have taken the downstream speed as sum of the speeds. But when we discussed about relative speed, we have learned that whenever two bodies move in the same direction, the relative speed should be taken as difference of the speeds. So friends, don't get confused that why are we taking opposite signs here. Understand this particular case of boats and streams is nowhere related to relative speed. Here, when a boat is moving against the water or along the water, it is not considered as relative speed because there is a physical contact between the boat and the flow of water there. In the previous case of relative speed, there was no physical contact when the two trains were moving in opposite direction or in same direction. So there the relative speed is taken as sum of the speeds in opposite direction and the difference of the speeds in same direction. But here, as you can see, when the boat goes upstream, the water which is coming from the opposite direction tries to pushes the boat backwards. So the boat struggles to move in the forward direction. Hence it takes more time. And when it takes more time, we can understand that the speed of the boat has reduced. So when the boat is going in upstream direction, we take the speed as difference of the speeds. Why? Because it is a reduced speed. Similarly, when the boat goes downstream, the water now is coming from behind and it pushes the boat in the forward direction. That is, it is helping the boat move faster. So as the speed has increased, for downstream we take it as sum of the speeds. So let me make it clear, don't compare these two speeds, that is downstream speed and upstream speed, with the concept of relative speed. Let us now take the first example from boats and streams, which is related to a man swimming in the river. Let us look at the question here. A man can swim with the stream at the rate of 3 km per hour and against the stream at the rate of 2 km per hour. How long will it take for him to swim 7.5 kilometers in still water? So as you can see here, a man can swim with the stream. We know that with the stream or along the stream is nothing but downstream. So a man can swim downstream at the speed of 3 kilometers per hour and against the stream is nothing but upstream. So upstream he can swim at the rate of 2 kilometers per hour. So very clearly the downstream speed SD is equals to 3 kilometers per hour and the upstream speed SU equals to 2 kilometers per hour. How long will it take for him to swim 7.5 kilometers in still water? So the distance which he has to swim is 7.5 kilometers and we need to find out the time required by the man to cover this distance. We know that to find out the time, we should have the distance and the speed. Distance is already specified in the question, that is 7.5 kilometers. Now the only thing which is required is the speed of the man in still water. Now we know that the speed of the man or the speed of the boat SB can be calculated as downstream speed plus upstream speed divided by 2. So this can be taken as 3 plus 2 divided by 2, as the downstream speed is 3 kilometers per hour and the upstream speed is 2 kilometers per hour. So 3 plus 2 by 2 is nothing but 5 by 2, which is 2.5 kilometers per hour. So very clearly the speed of the man is equals to 2.5 kilometers per hour. Now the time required by the man to cover this distance can be given as distance by speed of the man. The distance to be covered divided by speed of the man. Distance here is 7.5 kilometers and the speed is 2.5 kilometers per hour. So 7.5 kilometers and 2.5 kilometers per hour. Now 2.5 goes 3 times here. So 3 will be the answer. 3 hours. So the time required for him to swim 7.5 kilometers in still water. That is very important. Understand, he is covering this distance in still water. So that is the reason we need to consider the speed of the man in still water. Right? So that will be 3 hours because the units are kilometers and kilometers per hour, the time will be in hours. Let us now take another example from boats and streams. The question here is, a man can row 9 kilometers in 3 hours against a stream running at 2 kilometers per hour. How long would he take in rowing the same distance down the stream? So as given in the question, the distance covered by the man is 9 kilometers in 3 hours against a stream. That means he covered this distance upstream and the stream is running at the speed of 2 kilometers per hour. How long would he take in rowing the same distance? So he has to cover the same distance down the stream and we need to find out the time required to do that. Now we know that when a man or a boat rows upstream, the speed should be taken as, speed upstream is nothing but speed of the boat or speed of the man minus the speed of the stream, and this is equal to the distance covered by time taken to cover the distance. We know that the speed of the stream here is 2 kilometers per hour. The distance covered by the man is 9 kilometers in 3 hours. So from this very clearly the speed of the man will be equal to, this is 3 plus 2, that is 5 kilometers per hour. Now once we have got to know the speed of the man, we can find out how long will it take to cover the same distance down the stream. We know that downstream the equation can be taken as speed of the man plus speed of the stream, which is equals to the distance travelled by time taken to cover the distance. So here speed of the man is 5 plus speed of the stream as given here is 2 kilometers per hour. The distance to be covered is 9 kilometers divided by time. So from this the time required will be 9 by 7. It can be taken as 9 by 7 hours. Why? Because the distance is in kilometers and the speeds are in kilometers per hour. So the same distance can be covered by the man when he goes downstream in 9 by 7 hours. So friends, as you can see here, this is how simple is to solve the questions from boats and streams. We simply need to consider the proper equation, that is the upstream or the downstream equation. So as you can see here, the upstream equation is speed of the man minus speed of the stream equals to distance by time, and the downstream equation can be taken as speed of the man plus speed of the stream equals to distance by time. So with the help of these equations, we can just find out the missing variable and get the required answer. So these are the various concepts that are generally asked from time and distance. That's all from this topic. See you in the next session. Thank you.